Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It is my pleasure to introduce Shehzad. He's a PhD candidate at Michigan State University. His research interests are primarily security and protocol analysis and behavior-based authentication. So today he will hear about some of the work he's been doing while here at MSR for the summer. Shehzad.
Thank you, Arjman. All right, I've been working here for like 12 weeks now. This is my last week here. And I've been working on behavior-based authentication using signatures and gestures on touchscreen-based devices. All right, so why are we trying to find new authentication schemes? Because currently in computer world, we have mostly passwords and PIN codes. And if somebody else finds out your passwords and PIN codes, they can access your account. So we want to get rid of those. We want to not be dependent on those anymore. The research community has been doing a lot of research on keystroke rhythm, the typing rhythms of people, to use those for authenticating the people. That kind of eliminates the need of usernames and passwords. So you enter something, the computer finds out your typing pattern, typing behavior, and it finds out if it's you or not. But the problem is that it is still not a very efficient way of doing it because it has very high false positive rates still. And the thing is that whenever you have to log in, and if you want to use your typing rhythms, you have to type something, and usually it's considerably long, like 300 characters or something like that. So that's not very convenient. Anyway, so we were thinking that can we port such kind of scheme to touchscreen devices? The problem with touchscreen devices, when you try to port such schemes on touchscreen devices, is that touchscreen devices do not have a physical keyboard. So there is nothing really to guide your fingers physically. Like in keyboards, there are keys, so they kind of guide your fingers, so you have a typing rhythm or typing pattern. And another thing is that this kind of scheme does not work for people who are not very adept at typing. So you have to be very experienced, so you have to have a pattern, that only then they can work. So we were thinking that now that these devices have touch screens, so can we use something else? And of course, the first thing that we thought about was signatures. So can you use signatures to authenticate yourself on the touchscreen devices? And why not? Because signatures are very prevalent these days. They have been forever in financial institutions. And the reason being, it's even if you know somebody's signature, it's not easy to copy them. Like, why don't these banks and all these financial institutions use passwords? Because if I know your password, I can log in or I can access your account. But they use signatures. So signatures are more secure compared to passwords. But the problem with the reason why passwords are still more prevalent in computing devices is that there was no way to get signatures on your touchscreen devices, but now with on your computing devices. But now with these touchscreens and with very fine granularity of resolution that you can obtain of the points you're touching on the screen, I think this thing can be ported. I mean, signatures can be made to work on these touchscreen devices, and you can probably shift from passwords to signatures. Because if somebody knows your password, he can log in. But if somebody knows your signature, he cannot log in, because the way you do your signature is kind of very distinct. And that's what we are going to explore today. So for signatures, I'm not the first person doing any work on this thing. Especially, so people have done a lot of work on signatures, especially the static signature analysis scheme. So you have an image of the signature and you want to match it to another signature or your database. The problem with this thing is that the static image analysis is that what happens if somebody copies your signature exactly, like he spends some time and then he's able to copy your signature exactly. So that signature won't be, that signature will be authenticated by the static image analysis. The other problem is that these static image analysis techniques, which just use image processing to authenticate a signature, require a large amount of training data. I'm giving you an example. So there is a database, MNIST, for handwritten characters. It has like 60,000 training samples, and people have been doing a lot of work on automatic handwritten digit recognition. And the best accuracy that somebody was able to achieve was about 99.6% on that data set, and that is using about 6,000 samples per digit. So digits, you guys see, digits are very simple compared to signatures. So if you need 6,000 samples for each digit to get it to train so well that you get 99% accuracy, you probably need a lot more than 6,000 to train on your signature. And you do not want to ask your user to give you 6,000 training samples, and that's just ridiculous. So we were kind of thinking like, so when you're using touch screen, so you're doing your signatures, and the touch screen can basically tell you the behavior of the way you, like, it can tell you each point, what time you entered, what time you touched which parts of the screen. So can we use this information to reduce the training samples and also eliminate the problem of perfect copying of signatures? So I'm going to talk about that. So another thing that we thought about was, so can these signatures be feasible for all kind of touchscreen devices? So I have this one here. I mean, probably it works pretty well on this thing, but can you do it on a phone? You cannot actually. So I will talk about that as well. So we wanted to look for something else for phones, again, with not PIN codes and passwords, not something that you have to remember, but just something that you do on the screens of the phone, and then that is what you use for authentication. So you guys have seen that in Windows Phone, whenever you have to unlock the screen of the phone, you have to make a swipe. You first press the unlock button, and then you swipe upward to unlock the phone. On iPhone, you press the unlock button, then you swipe right to unlock the phone. So we were thinking, like, can we use just these gestures to find out if it's the original person or not? So that's what we worked on. We kind of make the gestures a little more sophisticated, not just little swipes, but something a little more sophisticated, and we use those to authenticate the user, and I will show that that is what we can do. I have the demo applications for both these things, and I will show it to you guys, and we will see. So the hypothesis behind all this work is that everybody has a distinct way of doing signatures. So signatures as well as gestures. So if I can do my signatures, anybody else, even if he can copy it, or the gesture that I perform on the phone, even if somebody else can do it, they will not be able to do it exactly the same way that I do it. And that is our basis of the work. That is how we distinguish between people. So rest of this talk is divided into kind of two parts. I will first talk in detail about what the signature authentication scheme that we have proposed is. I'm going to go in detail of not a lot of technical detail, but I will still give I will give details about how this thing works. After that, I'm going to switch to the gesture-based authentication on the phones. The technique that we use behind gesture-based authentication is kind of a subset of the technique for signatures. So I'm not going to talk about that technique in detail. I'll just mention what parts of the technique from signature-based authentication we borrowed for the gesture-based authentication. And then I will give you the demos, and you guys can try that as well. OK, so signatures. What is the objective here? So objective is first to find out if the signature is visually correct, if it's structurally correct or not. Like, does it look the same as the original signature that you are comparing with? And the second thing is, so once that is done, the second thing is that you want to find out if this has been done by the same person or if it has been imitated by some other person who made it look alike, but it's not the same way that they did the signature. OK, so I'm going to show you a couple of videos here just to give you an idea of. So you will see here two different signatures being done by two different people, and actually not two different people, they're my signatures, but anyways. So you will see 4 samples of those signatures on each of these screens, and you will see that they kind of look very similar when you do it. The behavior with which you do it, you will see it. So these are 4 samples of the signature from the same person being done, and you can see that they kind of look exactly the same when you do it. I have slowed them down a bit for you guys to see it. So all 4 are different signatures, but they looked kind of the same when you were actually doing it. I'm going to show you another sample here. And you will also see that there are some differences, sometimes a little lag in some particular part of the strokes, but there is still a behavior with which a person does his signatures. So we will use this fact for authenticating the signatures. So from this particular thing, we will extract velocities at different parts of the signatures. From velocities, I mean the magnitudes of the velocities as well as the directions. I will talk about this in detail later. The next thing that we should see is if there is a, so we analyze this thing that does a person have a behavior when, of the pressure when he does the signature, like the pressure on the screen. You can, I don't know if that's very clear or not, but you can see that there are some parts, always the same parts, which have lesser pressure. So the darker the dot is, the higher is the pressure. And there are these dark parts, and then there are lighter parts. So they're always the same in the signature. This probably will make it more clear. So these are the pressure plots of these 4 samples, and you can see that you have very distinct peaks at different locations. So this is one here, and then 2 here, 2 here, 2 here, and then so there are these at the start. So there are distinct peaks. So this kind of, again, is the behavior in the signature of the person. So you can use this information for authentication. This is another sample, and this is another pressure plot of the thing. You can again see that you have the same distinct peaks here, 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 here. And so you can extract this information out and try to use that for authentication. And another person who imitates your signature exactly the same way will not be able to follow this pressure plot. And so velocities is one thing that you can use, sure.
But doesn't this pressure plot also kind of follow from the shape of your?
No, so the thing, maybe I should have done that. So if you do your signature, try to do it a little differently, and then, or maybe a little slowly or something, your pressure plot will automatically change. So pressure is not based upon the shape. Pressure is how much pressure you're putting. So if you have a behavior, you will always press hard, press little, pull up your pen or finger, whatever you're using, and then so that kind of makes it distinct. So right now I've talked about velocities that you can use, the magnitudes of velocities, the directions, and the pressure. So the magnitudes of the velocities kind of give you the behavioral information. The pressure also gives you the behavioral information. The directions of the velocity give you the structural information. So you use the directions to find out if the structure of the signature is correct, like if it's visually correct or not. You use the magnitudes of the velocities and the pressures to find out if the behavior of doing the signature is correct or not. But there are other features as well I will talk about. Well, let's first see how to extract these features, because the thing is that you don't really know which exact. So there are parts of signatures which do not have consistent behavior among different samples. So you don't want to use any information from that particular part of the signatures, because that is going to increase false positives. Imposters will be able to log in. So you want to not use that information and use only that information from those particular parts of the signatures which have consistent behavior. So how to extract those features? So an easy way is to divide the whole signature into several substrokes. Each signature has several strokes. This particular signature has 8 strokes. So this is 1, 2, 3, 4, 5, 6, 7, and 8. So you have 8 strokes. You divide each stroke into several small parts, and then the thing is that you also have to figure out how small should this substroke be. If it's too small, it will kind of become instantaneous, and there won't be any consistency among different samples. If you make it too large, it will average out all the interesting information in it, and you again won't be able to find out what is, if there is any distinguishing information in it. So you have to have a correct size of the substroke. So there are 2 challenges. First, you have to find out what parts of the signatures have consistent behavior, and in those parts, what should be your substroke size, which will actually extract the consistent behavior. If the substroke is, again, too large, averages out, too small, it's instantaneous, you don't get anything out of it. To find the consistent features, you divide the substrokes, divide each stroke into substrokes of certain time t, I would say here. We use t equals 20 milliseconds, 30 milliseconds, 40, 50. So you divide each stroke into several parts of several substrokes of different time periods, and then take one particular stroke. I've made this one black here. So take this one particular stroke from all the signatures that you have, and then just extract the average amount of average feature value from this particular substrokes. For example, from this particular substroke, you can, if you want to find out pressure, take the pressure values among all the points in this substroke and take the average from the above, from the other substrokes, from all other signatures, take the pressure values, take the average. So you have, for example, if you have 100 training samples, so you have 100 of these substrokes, and you have 100 average values of that particular feature that you're using. It could be pressure, it could be velocity, it could be direction. Once you get the hundreds values of those signatures, those substroke features from all the signatures, you take their mean and take the standard deviation. And then try to find out if the standard deviation is large or small. If the standard deviation is large, that means this feature is not consistent among different samples of the same signature. If that standard deviation is small, then you can probably use it because the user has the same behavior every time. So we use coefficient of variation, which is just simply the ratio of standard deviation to mean. So we use coefficient of variation of 0.1 and 0.2. 0.1 and 0.2 means, so 0.1 means the standard deviation is just plus minus 10% of your mean value, which is very restrictive. The reason why we are using such small value of coefficient of variation is because it is okay to reject the legitimate user sometimes to not be able to log in, but it's not okay to let an imposter be able to log in even once. So you use small value of coefficient of variation. This will increase your false negatives, kind of might become annoying, but it will never let an imposter get logged in because you're allowing such a small amount of deviation in the feature values that an imposter may never be able to do it. So we take the coefficient of variation of each substroke in the whole signature and get the feature values and see if the coefficient of variation is below this threshold. For all the feature values where you have the coefficient of variation below this threshold, you use those feature values for training your classifier. If a certain feature has a coefficient of variation greater than this threshold, you just don't use it. You ignore that one. So using this strategy, this is what we get. So let's talk about directions. So this is the entire signature. So it is divided into several parts, and from each part we calculate the value of direction, and then take the coefficient of variation from each substroke. And then you see that these particular areas, the green ones, are always consistent. Their coefficient of variation of the value of direction is always less than 0.1. So you extract features out of these and you ignore the rest of the stuff. So whenever somebody will try to log in, he will provide your signature. You will extract the values of direction from only these parts of the signatures, and then you will try to compare it because these are very consistent. They are always the same for the legitimate user. So if they match, then he's probably the legitimate user. But these are not the only things that we use. So if you increase the coefficient of variation to 0.2, so 0.1 was this, 0.2 means you can use a little more information out of it. 0.2 is still acceptable, it's not too bad. So this is the other signature. These are the areas from where you use the values of direction. If you increase the coefficient of variation to 0.2, you extract values a little from a few more locations of the signature. From velocities, the magnitudes of velocities. If you use coefficient of variation of 0.1, this particular user does not have enough consistency. No, we didn't use any values here. If you go to 0.2, so you have quite a few places from where you can extract the magnitudes of the velocities. Same is the case with this user, coefficient of variation 0.1, no velocities extracted. 0.2, yes, you have enough consistency that coefficient of variation is less than 0.2, and you use these velocity values. If somebody finds out that there is, even for coefficient of variation 0.2, you do not have any feature values that you can extract, like nothing is consistent, you can keep on increasing the coefficient of variation. So it will let the legitimate user log in eventually, but again, if you use high coefficient of variation, there is a good chance that you will let an imposter log in as well. So all the users that I have studied, all the volunteers that I had, we were able to do it with 0.1 as well as 0.2, so we didn't have to go above 0.2. And I think generally 0.2 gives you enough features. For the pressure, we saw the pressure was kind of very consistent among different signatures. So we use a lot of parts from the signature for the pressure. So from both these signatures, actually. So there are other features that you can use. For example, total time of the signature. So for this particular user, the total time was generally 3.9 seconds, varies from about 3.7 to 4 seconds. For the second user, it varied from 2.8 to 3.2 seconds. So it's not too much variation. You can probably use total time of the signature as well. But we are not really using the total time of the signatures. We are actually using time of each stroke. That gives you enough. That is consistent enough. These are the other features that we use. Duration of each stroke in the signature. this gives you behavioral information. Inter-arrival time of strokes, that is the time between two strokes, like how much time it takes you to lift your pen or finger from one stroke and start the other one. So we use that. And then you also use the displacement between bounding boxes of the strokes. I will talk about what bounding boxes are. And so you extract all these features from, like you take all the stroke times, you take all the interstroke times, you take all the displacements between consecutive bounding boxes, and you again run the same test of coefficient of variation 0.1 or less, 0.2. If it's less than that, you use that feature, otherwise you don't. So this is one signature of one of the users. We can see that interstroke times, like the time between two strokes and the time of strokes, the coefficient of variation is pretty reasonable, less than 0.1 in most cases here, less than 0.2 in most cases there. Sometimes in some signatures, some stroke times do not have coefficient of variation less than 0.2. We just do not use those stroke times. So this is what I meant by bounding boxes. So bounding box of each stroke means the smallest rectangle with smallest area that bounds that stroke. So you take that box and like basically join the centers of all the consecutive boxes, and you can see that each user, so all these four signatures have kind of the same pattern. The location from at which a particular stroke is located compared to the other stroke is kind of usually the same. So this previous thing showed the coefficient of variation of direction and the distance. So distance means this distance, and directions means which direction. So coefficient of variation of direction is always very, very less. So that is a very good feature to use. So we use that feature, and in some cases you can also use the coefficient of variation of the distance between bounding boxes. So that's also usable. So till now I have talked about what features we use that include velocity, the magnitude of the velocity, the direction, the pressure, stroke times, interstroke times, and displacement between bounding boxes. So these are the features that we use to identify a signature from the other signature. We train a classifier, I will talk about that, and then we do the testing, and then that's how it works. But before I do that, there's one last thing that I want to talk about, is this. I'm not going to go in the exact details. If somebody's interested, we can take it offline. But so sometimes when you're doing, so this is kind of the signature that generally looks like from a user. So it has 8 strokes here. So you can see, so these two signatures have 7 strokes. This particular stroke is combined, and these two strokes here, they're combined. So so we came up with a way to basically separate them. So if you have 7 strokes, there is no way you can make the substrokes and then correlate and try to find out which substrokes you should extract features from. So you first need to make the number of strokes in the signature consistent, and then after that you extract the features. So generally what effectively we do is we take information from all the strokes of the training data, and whenever a problematic signature comes in, we take all the strokes, and then we try to find out which stroke you should split, which stroke is not consistent with the training data. And once you find that out, then we again use the training data to find out which exact parts of this stroke you should split from, and then you remove that certain parts from the stroke, and then you get your desired number of strokes like this. So for this one, we just remove a little bit of thing from here, and it divides it into 2. For this one, we remove this part, and then it makes the number of strokes consistent. All right, so that is all the feature extraction part. After that, it's simple. We take the support vector distribution estimation. It's a one-class classification, so you do not have any information from the other imposters class. So all you do is, so there is open implementation of SVM, one-class SVM. It's called support vector distribution estimation. That's available online. So we use libsvm for that. We took these features, trained our classifier, did some grid search for parameter optimization. I'm not going to talk about that because that is a standard machine learning part. So we did that, and it works out pretty well. So let's see. I'm going to give you a demo of this thing now. And after the presentation, anybody's welcome to try to do these signatures and try to log in. So I'm not sure if I'll be able to do it here or not, but generally I am able to, so please trust me. Let's see. So it tells you here that it's a legitimate user. These are done by me. I'm going to do it again. I will make them look exactly like this thing. I mean, I cannot make it look exactly like, but I will make them look similar enough that a person, if he just visually sees them, he will say that this is from the same person. But I will try to do it differently, and then it will tell you that it's not the same person. I mean, these are kind of hard, but if you want to try it, you're welcome to.
Does it matter whether the user gets visual feedback when?
The reason why I'm not getting, yes, it matters. If you have visual feedback, we have not done that, but I think it's going to be much more convenient for the user. The reason why I'm not doing that is because I need to have very good sampling rate. And if I try to draw the thing on the screen, it kind of reduces my sampling rate. And when it reduces my sampling rate, it reduces my accuracy. So see this? So this one's imposter, this one's legitimate. And they look exactly the same to naked eye, right? So I mean, of course, there will always be differences. You can never do your two signatures exactly alike. But I mean, if I send it to the bank, probably they will accept it. So this is the idea behind this thing. OK, so that was the signatures part. Now let's move to the gestures. All right, so why don't we just use signatures on the phone? I mean, how hard could it be? This hard. So this was the best that I could get out of my signatures. I do both of these, so this is what it looks like on the phone. Maybe you can have some accuracy here as well. We didn't try that, but I don't think it's going to be very good because it's hard to imitate your own signatures on the phone. The screen is small. You don't have any place to rest your hand, and then it makes it hard to do your own signatures on the screen. And again, I mean, if you are driving, you probably do not want to do your signatures to unlock your screen, right? So there should be an easier way for the phones. So what do we mean by gestures? So these are the gestures that we have. We have 10 gestures. I started with 39 gestures, so I gave a few phones to some volunteers. We've got like 40 volunteers, so they performed those gestures, and we analyzed them. We saw which gestures have distinguishing features, which gestures do not have. Like the swipes on the iPhone or the Windows phone, they do not have distinctive enough information. But if you make it 2 fingers or 3 fingers in different directions, or if you make it like some curves and pinch, like zoom in and zoom out, that has a distinguishing information in it, and you can use that for authenticating the person. So these are the 10 gestures that I have in my final demo application. So what we do is we ask the user to do the training, provide at least 30 training samples for each gesture. 30 is the minimum, but the more the better. So we take that information, and then we train our classifier. I'm going to talk about how we do that. So the basic thing behind the whole scheme is almost the same as signatures. Here, each finger basically represents a stroke. You divide each finger stroke into several substrokes, and then extract features like velocity, time, bounding boxes, displacement between bounding boxes. We're not using pressure here because our phone could not give us the pressure information. So that feature is not being used. But I think that if the API for the pressure right now is not available, but it will be available soon. I read it somewhere. So once that is here, once you use the pressure information, it's going to make it much more robust, I think. Because pressure is something you probably cannot figure out by just watching a person do a signature. You can see how he does it. You can see all the thing, but probably not the pressure. So once the pressure information is available, we'll use that probably and see how it improves our accuracy. And again, the same thing. We took those features, trained our classifier, tested them. So as I mentioned, we have data set from like 40 users. So what we do is we take all the data of these 10 gestures from any user who wants to train, and then use all those 40 users as imposters and try to rank which feature for this particular user is most distinguishing. And once we rank them, then we send that information. So we do this in a cloud service. We send that information back to the phone. The phone then asks you automatically which gesture you should perform, and you perform those gestures, and then it uploads the information back to the cloud, and it does the classification and tells you if that is you or not. If you can use, so if you want to be more secure, you probably want to do like 3 gestures or 4 gestures or 5 gestures. If you want to be, if it's just okay, you can do 1 gesture. And so 2 gestures, 3 gestures are probably actually going to be more secure compared to 1 gesture. So, and that brings me to the demo of the phone. This is what you guys can try because, so I've already done it once. It tells a legitimate, then you guys can try it, whoever wants to do it. Take the phone and do it. Just press the test again button, number of features selected 3, and do that, and see if you can imitate that or not. So the phone is here. The last thing that I want to talk about is how to do the training. One interesting thing that we observed while doing this work was, so I sat down and I did 100 signatures as training, and I tried to test myself again. So I did the 100 signatures on training. I trained them. I did all the simulations in MATLAB and found out that I'm getting like 99 out of 100 signatures being identified correctly. And same is the case with some other volunteers that did in the same way. Sat down, gave me 100 samples. So apparently looked it's going to work pretty well. But when we actually made the application and the user again tried to sign and we give that information, give that signature to the to our testing server, it wouldn't recognize that person. So that was kind of strange because, so if we had 100 samples, we are training on 99 samples and testing on 1 sample, working perfectly fine. So we are training on another 99 samples, testing on the remaining 1 sample, working very good. I mean, so it was able to recognize them, but why not the signatures that you're getting on runtime? And we found out that once you're trying to do your training, once you're giving all your training samples in 1 row, you kind of develop a pattern which is not your natural pattern, and you cannot imitate that again. So if you start doing your signatures 100 times, you will actually see that you are doing it in a very distinct way, which is very, very consistent, gives you very good accuracy on simulations, but you cannot imitate that after half an hour. That becomes hard. So we did again. So what we did again was I asked several users, including myself. We did training 10 samples at a time and with several breaks, half an hour, days of breaks. And once we did that, then it started working. So that's kind of thing that you have to do in the training, and that's kind of thing I have seen in some of the earlier work. They have done this kind of work on phones and some of them on tablets as well, and they have very good accuracies of simulations, but I think that's not going to work in real life. So you have to do the training like this. Just don't take too many training samples at once because you develop patterns which are not your natural patterns. I would suggest like 5 samples at a time, and then take breaks and then train over a period of time, like maybe a week, and then do it, and then it works pretty cool. So that was about what my work here was. Any questions?
Yes, I was also wondering about accuracy when you want to use your tablet in the morning or in the evening after you come home from partying, since then probably
I was kind of worried when I came here because when I was going to do my signatures while standing, I have done all my training and all my testing on myself always sitting. And when I was trying to do it here, so I kind of thought that I may not be able to, but I was able to. If you're doing your signatures, if you have been doing them for a while, you can do it. So that doesn't really make too much of a difference. You always have a pattern. And our scheme, I did not talk about all that stuff. It does take into account, like, for example, if you increase your actual time so if you do generally in 4 seconds, and if this time you do in 5 seconds because you're a little lazy, it can still figure out using those 5 seconds as reference that, well, even if you used 5 seconds, does your rest of the stuff has behavior in it? And it will have. So you normalize with your total time and all that stuff. So it works on different things. For the gestures, yes. So in gestures, you do see this problem, and we plan to work on it in future. That, for example, if you are driving or if you are nervous probably or something, that kind of makes it hard for you to log in. But if you are in a normal state of mode, or like if you're walking, it's probably going to be a little hard. If you're driving, it's going to be hard. So the best way to deal with that is train it in all different scenarios, and it will work. Yes, please.
Is it something that if you add more and more training sessions to it over time, it becomes more and more accurate?
It does, but that depends what kind of training are you doing. If you are just putting in random samples, it's probably going to get worse. Like if you just think that you're going to do it again and again and again and don't care about being consistent, then it's going to make it worse. But otherwise, yes, it makes it better. So the training part is tricky. You have to be very consistent in that, and you have to be patient with that, because it becomes kind of tedious. So it frustrating a little bit. But if you stay consistent in that, it works pretty well after that. Yes.
So you looked at full signatures for authentication. Did you look at anything shorter, like say just the first part of your name or some kind of made-up gesture? That way you're not having to authenticate with your signature.
Made up gestures? No. We didn't ask people to do random. I think we did, but we didn't do that analysis.
Okay.
So we have a list of gestures right now. We just analyzed those. Again, the thing is, so the main idea behind our work was to understand the behavior, to use the behavior of doing something. If you just make up something right now, and if you do it right now, train it right now, and do it afterwards, you probably won't be able to do it again. So in order to get rid of the passwords, you need to have something which is consistent. Maybe handwriting. I don't know. I have not worked on that. Maybe just write something and it can recognize.
Any other questions? Well, let's thank Shehzad for his wonderful